Good morning, students. In today's class, we are going to discuss about the implementation of linear regression. As we all know that how linear regression works, and we discuss in the theoretical in theory classes of linear regression. Now, I'll just give a quick overview, then we'll start further. So, we all know that linear regression is a statistical model which is used to find the relationship between the dependent and independent variable. And our primary goal of linear regression is to predict the value of dependent variable based on the value of independent variable. You can take a simple example. I have a size of the house, location of the house, and the distance from the city. So all these features I am having. So using these features, I want to calculate what could be the price of my house. So what we are doing, we are trying to find the value, we are trying to find the values so which is depend on some other variable. So there are some independent variable and some dependent variable. So what is dependent variable? Dependent variable is what we are trying to predict. So the value which I want to predict, the value of house which I want to predict, the price of house which I want to predict is nothing but my dependent variable, or we can also call it as target variable. Independent variable is nothing but the variable which are used for prediction purpose, which are used for prediction of the dependent variable. Those variables are called independent variables. Linear relationship is nothing but the relationship between the dependent and independent variable is called linear relationship. So this is just a quick overview of linear regression. Now we'll go with the implementation part. So before discussing about the implementation part, I want to tell you that what data set we have used for linear regression implementation. We are using here California housing data set, which is a popular data set in the machine learning community, and mostly this data set is used for regression purpose. Okay, and this data set includes the information which is collected during the 1919 California, and this data set is basically used to predict the house value. If I want to predict the house value, I can use this particular data. It consists of several features. Okay, so this is the data set description. Now we'll discuss about the implementation part. So as we all know that whenever I'm trying to implement any machine learning model, I have to import the specific libraries. So these are the libraries which I have to import. I'm importing NumPy and Pandas. Okay. At the same time, from sklearn, I'm importing the train and plus split because I have to split my data into training and test. And I have to import the linear regression because I'm implementing linear regression. And if you want to calculate the mean square error and R2 square score, you can import those libraries also. And if you are trying to draw some graph, you can import matplotlib. So these are the libraries which I'm going to use for this. So we are imported. Now the first thing is, first we are importing the libraries. After importing the libraries, now the next step will be we are loading the California housing data set. So I'm trying to load my California housing data set here. So just we are fetching the data from the sklearn library. So we are taking here from sklearn data set, I'm importing California housing data set. And after importing that data set, I'm keeping in a variable which is my housing variable. And now I'm converting that data set into the data frame. As we all know that whenever I'm working on any CSV file, I have to use data frame. So I'm converting all the data into the form of data frame. Fine. And I'm assuming that the house value is my target variable. So I need, as you all know that I need input features and the variable which I want to predict. So that is my target variable which I want to predict, that is dependent on the other features. So I need both the features. I need input features as well as I need target features. So target feature I'm keeping separately and I'm keeping in a MEDV variable. Fine. So this is all about the data set loading. After that, just I want to see that what exactly the features are available in my data set. So I'm using df.head, data frame.head, which is going to print first five rows of my data set. So you can see these are the features of my data set. Okay, so these are the features of your data set: the age of the house, the average rooms of the house, the number of bedrooms, the population in that particular area, latitude, longitude, and the final price of my house. Okay, so these informations are available in my data set. So this is about your data set. Now, whenever we are implementing any machine learning algorithm, we know that we have to perform some of the pre-processing, which is used to clean the data. If your data is a raw data, you cannot directly give to the model. So you have to clean your data. That is nothing but the pre-processing. So first of all, I have to check there is any missing value in the data set or not. If there is any missing value, I have to remove those missing values. So I want to check there is any missing value or not. So we have using here function is null function, and I want to take the sum of all the missing values. So we are using here df.isNull.sum. Okay, so you can see here when I'm printing this, there is no missing value in my particular data set. It means my data is fully clean. I don't have any missing value available into this. Now I want to print the features and the target. Okay, the same way I want to print the features and the target, and I want to drop MEDV column from my data set. Okay, I want to drop from the features. I want to drop from the features, and I want to keep that into the target variable, because I want to make a separation between the target values and the features. So what I'm doing, I'm keeping here x variable, and from there I'm dropping my MEDV feature. Okay, because it is my target, and that feature I'm keeping into target. So x is containing all input features and y is containing my target value. Clear? So we have defined here features and the target value. So this is your pre-processing and defining the features and the target variable separately. Now the next step will be, now I have a proper data set available with me. Now I have to perform the training and testing. Okay, so before performing the training of the model, I have to split the data into the training as well as in the testing part. So what I have to do, I have to perform splitting of data. So I have to split train data as well as the test data. So I'm using here variable x train for input features and y train for of your target training data. X test is used for X test we are using for testing purpose, which is containing the input features, and Y test is containing your target variable of test data. Now I'm splitting the data. After splitting the data, I'm keeping into X and Y. The splitting is done. 20% of data I'm using for testing, and 80% data we are using for training purpose. And we are using here random state. Why we are using random state? So if you want to fix the value, because every time it is randomly splitting your data into training and testing. So so if you are executing the same program again and again, so what will happen, it will take randomly different values, and the accuracy will be different at different execution. So we want that accuracy should be same. It should choose the same value after in every execution. So you have to fix and your random state value with some value. So we are keeping here random state equal to 42. You can keep anything. Okay, so this is the splitting. After splitting, what I have to do, I have to fit my model. I have to build my model on my training data. So I'm calling linear regression function here because I want to create a linear regressor. So I'm using linear regression. Now I want to fit my model. So just I'm using model dot fit. So when I'm using model dot fit, what I'm giving to the model. So during training, I have to give input features as well as the target also, because in the training I have to give both to learn the model. Model has to learn that what could be the outcome. So I have to give input as well as the target features also. So we have built a linear regressor here. Finally, after building a linear regressor, now I want to predict and evaluate the performance of the model, that how much my model have learned during the training. I want to predict on the test data set that how much my model is giving the accuracy. So for that, I'm using what? I have to use the test data set. Okay, so I'm using the test data set, and I'm trying to predict the performance of the model. So I'm using model.predict, and I'm passing the value of test data set. Okay, and I'm keeping the result into Y prediction. And to evaluate the performance of the linear regression model, I told you in earlier classes also, we can use mean square error and R2 score. So I'm trying to evaluate the performance of the model using these two functions. So when I'm using mean square error, I have to give two values. One is input, one is actual value, which is represented by Y underscore test, and Y underscore test is Y underscore predict is representing the predicted value in the during the testing. So I'm passing these two values for mean square error as well as R2 score. And finally, I'm printing the result of mean square error and R2 score. So you can see the mean square error is 0.55 and R2 score is here 0.57. So we have done the prediction on the test data set, and we have evaluated the performance of the model using mean square error and R2 score. Fine. Now I want to do the visualization of my model. I want to display some of the graph for better visualization. So I'm plotting my results. So I want to plot a scatter plot on my data set, on my actual data set as well as in the predicted data set. So just I call plot dot scatter for actual value between the actual value and the predicted value, and I want to give the label to the model. So x is containing actual MEDV and y label is containing y axis is containing predicted MEDV, and I want to give the title to the graph, which is actual versus predicted MEDV, and finally I want to display on the screen. For that I'm using plot.show. Fine. And at the same time I want to print the coefficient and intercept also. So for that I'm just using model.coefficient and model.intercept. So you can see the final result. So this is representing the actual value, what my actual value in my data set, and this is representing what the values we have predicted through the linear regression. Okay. So this is your graph, and we have printed the coefficient also. So this is representing my coefficient and intercept value. So I hope it is clear to you that how linear regression performs. So whenever we are trying to implement any machine learning model, we have to follow certain steps. Just I'll give a quick summary of that. I have to import the libraries first. After importing the library, I have to load the data set. Next step will be the pre-processing of the data set. Once the pre-processing has been done, you have to split the data into training and testing. After splitting of the data, you have to train the model using fit function. You will fit your model. After fitting the model, you will predict the results. Okay. You will predict the difference between the actual value and the predicted value. And now if you want to check the performance of your model, you are going to use some evaluation matrix. And if you want to visualize your data, you can plot the graphs. So this is common for most of the machine learning algorithms. So this is all about linear regression. In next class, we are going to discuss about the logistic regression. Thank you.